Mellissa, you said something that really caught my imagination. I think it's a great way to start our conversation, which is we need to rethink how we're moving cooling around the data center. I've been around a data center for a long time. When you said that, what do you mean by that?
So when it comes to data centers, we have historically built them, and specifically the hydronic system, the same way that we build almost every other type of building. So whether it's a school, a hospital, an office building, we built the hydronic systems the same way in the way that we move liquid around. And that means that we assume a fairly static condition, that we have a set design condition and assume it's going to stay relatively the same, let's say plus or minus 10% through the life of that system. And any change to that has to be a major redesign. When it comes to data centers, we know that they're not going to be static. They haven't been for a while. And the trajectories we're seeing of heat densities, we're going to have a lot of changes in the way we need to cool the systems, whether it is just more cooling of the same type or transitioning to liquid cooling or hybrid cooling, that the way we need to adapt to be able to cool well today and cool well in the future is different than we've been designing these systems historically.
I've heard some version of this so many times in the last 6 months, it's almost scary. And it goes something like this, very similar to what you said. We engineer to a design, like why wouldn't you? Of course, you know, to a tolerance or to whatever. But the swings between the tolerances can be so big that if you don't have the ability to adjust in real time or near real time, it's not just a matter of efficiency in terms of power consumption or whatever. It is can be wildly cost impacting. It can be performance impacting. It could be, there's so many ways that can sway, that whether you're creating GPUs, whether you've got servers in a rack, whether you've got telecom coming into the facility, the swings are so big within allowable tolerances. You've got to be able to react in real time, or not so much that you would break things, but you would just be wildly inefficient in a wide variety of ways. And it sounds like you're saying a similar thing in your world.
Absolutely. So when we look at the way we have historically built, without getting too much into the weeds as far as design, we say that they're statically balanced, that they put in a pressure dependent valve and a balancing valve, and a balancer goes in and balances it at that condition, that it's basically at full load, and they assume it's going to operate that way for most of the life of the building or until they replace something and rebalance it. When we're talking about these huge swings, you may have a building that was originally designed for all air cooling. It may be air handlers, craw units, whatever approach they may be taking on the air cooled side. And then they start adding in liquid cooling, let's say single phase cold plates, and they're putting it on the exact same loop. So now you have these two different dynamics in the space, that you have some air cooled component and some liquid cooled component. The rate at which they have to react and the speed at which you need to have cooling to those different devices is completely different than we've had. When we talk about the statically balanced system, you don't want to have the change in flow rate in one of those zones affecting the flow rate in the other zones as they open and close, because we're also talking about equipment, if we're talking about single phase cold plate and going directly to the GPUs, that they are much more sensitive to the changes in flow rate, and you need to maintain the flow rate on the low end and the high end.
Let's pause for a second. If I was deploying a data center 5 years ago, maybe even more recently than that, but let's just say 5 years ago, am I as sensitive to this conversation then? And the reason why I ask is there's always been a conversation, or regularly been a conversation, about the potential change in rack density, meaning they're going to get hotter, the user's going to use more capacity. So if there's a potential in a rack, and so when I say rack, I mean a cabinet full of servers, right? IT gear, could be telecom servers, whatever. And that rack, we have the ability within the space in and around that rack through air cooling primarily to mitigate the heat load. So whenever I'm using power, I create heat, and so I've got to remove heat from the environment so that the systems can operate at peak efficiency, and it's safe for not just the machines but for the humans that have to be in that space as well. And it was common in the co-location side of things for that rack to operate at about 30% of what it could operate at, what it was designed to operate at. And for one of our really big enterprise or hyperscale customers, they've really spent a lot of time maximizing their efficiency. Somewhere between 60 and 80% was pretty common, again, with air cooling. So that's 5 years ago, maybe a little bit more recent than that, but that would be, we've got a pretty big portfolio, and that's probably accurate across the spectrum. Well, now that's not the conversation. Most of the organizations that we're talking to are looking to get up to 90% of their, or north of that if they could, but they need a little bit of margin. But the low water mark's not 30%, it's not 50%, it's 60% at their sort of stabilized condition. They want to be at 90% of the potential of that rack. And then they want to increase the potential. So if that rack in the past could be 10 kW or even 12 kW with containment in an air-cooled solution, in the near term, I'm trying to be very conservative. I'm sure you guys hear other numbers, but at least double that, if not triple that. And that's probably in the next 24 to 36 months. Some new deployments much sooner than that. But it's difficult to change an entire topology and whatever. But in the old deployment, that's what we were looking at. 30 to 60% of the potential is going to be used, and the potential is going to be around 10 kW rack. That doesn't seem to be across our portfolio, my industry colleagues, even the people that are speculating the future, that it is going to be significantly different than that. Are you hearing the same thing, or are my numbers way off?
Oh, I'm hearing the exact same thing, especially when you're getting into, I'm going to call them super high density servers. If someone's investing in, say, an NVIDIA super pod, they're not going to buy it and buy essentially a Lamborghini and run it like they're running a Chevy. That's right. I see them all running at higher capacities within their availability because they have more to use, more to play with, and that's what they're going to do.
It's so from your perspective, how is that impacting design? And before you answer, for years, decades, ASHRAE, who is a body in our that not just data centers, not just critical infrastructure, but a number of entities use as like a guidance. Like, these are the operating parameters we would recommend that you operate electrical loads, heat loads, et cetera, in a critical environment. So they publish guidelines. And they have said forever you could operate or should operate at a certain temperature level. And the industry has been reluctant, probably like me. We grew up as IT people first, and we wanted our server rooms, what we used to call them now, data centers, to be cold, especially somebody my size. I don't want to walk into something hot. I want to walk into something cold. And now there's a lot of momentum for a number of reasons to really embrace those ASHRAE guidelines, to actually deploy following those guidelines. So as you evaluate that from your position, how is it impacting how you're designing? Because you still got to accommodate loads of today. I mean, there's this hybrid world, right? I got loads today, a wide variety of customers, but I've also got to have enough flexibility that I can adjust for the loads that are coming in. So can you help us understand what it is that you guys are thinking about when you create these designs?
Oh, absolutely. And I'm glad you brought up ASHRAE and TC 9.9 because they are doing a lot of work in that space and have some really good guidelines. But historically, they've had their recommended and then allowable ranges. And if I even go back 3 years ago, I saw most data center owners and operators working in that recommended range. And now I'm seeing it pushed more and more out to that allowable range. I was just talking to a customer last week that is wanting to operate at 50 degrees Celsius, which I wouldn't have been having that conversation with them 3 years ago. So pushing wider. So with respect to what we're doing when we're talking with whether it's consulting engineers, GPU manufacturers, or owner operators on what we're doing is how do we take a design and we're no longer at that static condition. Say you're designing a new data center today and what we're planning for, trying to take in all the inputs and we're working with the best information we have available as far as temperature ranges in that allowable range, looking at what the potential heat densities could be. If I go back to ASHRAE TC 9.9, they do power trends that they release. And to be part of that IT subcommittee that develops those power trends, you have to work for an IT manufacturer. So I see representatives on that group from NVIDIA, Intel, Dell, AMD, companies of that nature. And every time they release these power trends, they shorten the time frame of which they're willing to project. So the first generation, they projected out 10 years. Now I think they're only projecting out 7 years. So these are who I consider the experts in the industry who have the best possible information available as far as what's coming, and they still aren't projecting out further than that right now. So if I'm having to design, I'm taking all of those inputs, but there's still these huge question marks of what if. So we have to take those design conditions and add all of these variables and question marks. So what it means for us when we're talking about how we're going to move water or liquid, not just water around, is what could it potentially be? Not just this design condition. Is it going to be that same kind of loop in 5 years? Is it going to be serving CRAHs? Is it going to be serving liquid cooling? Is it going to be connected to a cooling distribution unit instead? There's all of these variables that we're looking at the what ifs and having to bring in smarter devices. Our current designs spend a lot of time with measurement and data, but it looks in the rearview mirror. If we have a control valve and a flow meter, they generally don't talk to each other. It's generally feeding data into a particular control system and they're taking a look at it, but we're looking in the rearview mirror. Moving forward, we can have much smarter devices where we bring those together and make smart decisions in real time and can help right size the performance depending on the given condition. What I mean by that, when you have all that information together in one component, whether it's flow meters, temperature sensors, BTU meters, and it's all feeding that information together, you can be looking at the whole picture and making those decisions in real time to say, this is where I need more, this is where I need less. I'm changing my flow rates here very quickly. I'm having to shut down, let's say they pulled a server out of service on a single phase cold plate. They can shut down that one trunk line, so to speak, to that server, and the rest of the servers, the flow rates remain unchanged, and you have full visibility to that system.
That's a lot. That's a lot going on there. It's just as you were talking. By the way, for our audience that doesn't know, what's a CRAH?
A CRAH is a computer room air handler. So it's how the most common type of cooling an air-cooled data center where you have a big fan and a coil with chilled water flowing through it that cools the space.
I love those things, but my operators hate me getting near them because I tend to lean against them and just rotate. They keep waiting me to like float over them like one of those parachute practice things. But anyway, I digress. Hey, let me ask you this. So with all, even if we wanted to do it in real time today, to adjust, like let's say we had all the inputs. We had the inputs, we had we weren't looking at past performance to adjust. We're looking at real-time data or near real-time. Like it's actionable. It's going on around me right now. As we've looked at a variety of tools in my space, it is apparent to us that to do this without system intelligence in real time for a human being, even a really smart, really capable, really experienced human being, is impossible. I mean, it's just too, especially the size of data centers, if I extend that to a campus, it's just impossible. How are you thinking about like the intelligence? You know, I love to call them the software-defined data center, but in the same way that I have apps that help me do a million things, and they live on my phone or they live on whatever. Doesn't there have to be some role of artificial intelligence here, or maybe it's machine learning and not AI, but some tool that comes along here to help your operators evaluate what's going on, take action, approved action, not just willy-nilly, approved action. And we haven't set this up, so if I'm more forward-thinking than it's actually capable, but that's what it feels like it has to be. And then to orchestrate, certainly the orchestration part, right? Hey, so-and-so, go take action tool. It seems like you'd have to have that ability to take action and then measure the impact of the action as you take it.
Oh, absolutely. I see it in two different ways. Yes, there's definitely an AI component to it when you have all of that data being fed up and being able to make some real-time decisions. But I'm also seeing systems where I'm going to say the control system is more I don't know what the right terminology would be, but where there's a lot more smarts in each of the individual components. So I would call it more of a distributed control system. So a lot of that logic, so it's not the operators having to take action. There's already processes and control sequences contained in there. So it's making decisions. The control system is based on the inputs that are already predefined. So it's making decisions, and you don't even have to have intervention by an operator unless something goes well outside of parameters. So it's making it far more automated than it has been in the past when you have all of those smarts together within, I'm going to call it a distributed control system.
That sounds right. One of the things that I've always found interesting when we've tried to design data centers and deploy them, we'd have to make a choice. Do I want to design for flexibility, or do I want to design for optimization? So am I designing for something that when it's fully populated, it's fully optimized, I get the best possible bang for my buck. So if I know that I'm going to be hauling 40 people to the office, then I'm gonna try to design a bus. But it may be 6 months or a year before I get to where I need the capacity for all 40. Or do I want something that's really agile? Today I might be rural, tomorrow I might be suburban, and so is a bus going to help me because it's not as flexible? So I might have to make a whole bunch of trips instead of one efficient trip. And as we're designing data centers today, and we're looking at our crystal ball, it's not always clear. We know more. But what happens when that environment that we've deployed, it's a learning module for a big AI, and so it's learned, and now it needs to be repurposed and retooled. Well, that building is 100, if not a 200-year facility. It's wildly inefficient, if not catastrophic for the environment, to be tearing down and rebuilding buildings all the time. And so I want that perfect situation where it is agile, just in time, and yet at full stabilization is wildly optimized. Is anybody else thinking about that? Are we approaching future designs with that in mind? How can I be agile enough today, or be able to optimize for today, but be agile at the same time so I can reconfigure as I need to and still hit my optimization goals?
Yes, it's the short answer. Some are. It's definitely slow to be adopted, in my opinion, but there are components out there today that allow both, that allow that agility and the optimization because they will work well at both conditions. Obviously, there's limits to that of how far you could oversize it, so to speak, for today's conditions and still have it work well. But I'm seeing a few specifically consulting engineers, designers, and some data center owners that are looking that way. I can't name any names on here,
Sure.
but there's a few that are looking that way of how do we essentially oversize the physical components now and have them not behave like they're oversized and have them then perform at the right uh, uh, conditions so that they are even optimized today. And then as they grow, whether they're going to double or triple or quadruple in load in the next 10 years, that they can operate well at those conditions as well. I like to think of it like some of the newer engines that they're putting in cars now that they will unload when they don't need the capacity but the power is still there when they need it. We're able to do that now with the components and the hydronic systems as well. There's so much more versatility, but it's the adoption that is the hesitation. There's a gentleman in the industry by the name of Peter Gross who has a statement he made that I hear over and over again, and it rings so true with me, that the data center industry loves innovation as long as it's 10 years old. And I absolutely agree with him, but I would say sometimes it has to be even older than 10 years old for them to love it. And that's where we're at, is we're getting some of the folks that are getting on board with it and really looking at that agility and the optimization together. But there's a lot of we've always done it this way. Why don't we continue doing it this way, even though what they're going to need to do with their buildings for both density and environmental conditions is going to change.
Look, that's fair. That's amusing. I've heard Peter speak many times. I've not heard that statement, but it rings so true. But and I know Peter knows this. Here's the challenge with a data center. Now, not every environment within a data center has the same resiliency requirement, but many data centers certainly, or environments, certainly in early days of data centers, very rare was it that somebody took an environment and put it into a data center that didn't need to be, the promise was, the ask was 100% up 100% of the time. Now we would put in contracts that's 5 nines or concurrently maintainable or some other thing, but those were all words to say, including maintenance. I expect my Sheriff's 911 system to be up all the time. I expect if somebody comes to buy a widget from my website, it's available all the time, that there is never an incident when it's not up. And there are many environments that it would be a catastrophe if it wasn't available. And so those of us that have been in the industry for a long time, it's hard to shake that off, because we would design, when we would deploy, you would always design to the strictest requirement. The strictest requirement encompasses the least restrictive requirement. And now we're seeing that we need more agility within that facility, that not all of the environments need the same level of resilience. For example, your car analogy. While I'm driving, a buddy of mine, I'm pretty sure I have a heavy duty truck because I pull a big trailer. We've got 4-wheelers and 2-wheelers, and we look like Tour de Georgia driving down the road when we're fully loaded. But there are other days when I drive that truck to work that it only needs 2 cylinders. Now it's older truck, so it doesn't have that ability, but my buddy's truck that could probably outpull mine has the ability to power down 60, 80% of its powertrain, and it runs wildly more efficient and will probably last a lot longer. It only spins up the whole potential when it needs the whole potential. And so I could see a need. Anyway, I think the mindset when Peter refers to us, and I know he does it with affection, but it's true because we think of that whole, the whole Death Star's got to work, and it's got to be this way. But the fact of the matter is there's a lot of environments within our facility. And even if that environment today needs to be 100% up 100% of the time, 5 years from now, that may change. And I need the agility to not just grow its capacity of density, but to reduce its level of resiliency because it's not needed. They don't want to pay for it. The infrastructure doesn't need it, whatever those reasons are. And it's very difficult if I'm doing that at a static level where I'm doing it with components that don't have a brain attached to them, because then I got to swap out a whole bunch of components. And I see people get anxious really quick, go wandering into a data center floor with a hammer and a screwdriver and a box full of parts saying, I'm going to go adjust me an environment. That does not thrill anybody.
Yes, absolutely. That's where I look at the increase in resiliency as we have smarter components, assuming people trust in the smarter components, that when they're able to make those decisions and they have certain bounds that they can operate in, that you're not having to depend on an operator going out and making those decisions on a one-by-one basis, so to speak, that you're able to do a lot more of that and have it done automatically within the system.
That's a great point. So how do you instill confidence? And the reason why I ask that is I remember when pilots, I have a number of family members that are pilots, and all of their systems were analog. Now, very few planes are strictly analog. There are a few, but most of them are digital. They have digital glass, and they've learned to trust these systems. They believe they are equally accurate, if not more accurate in many cases, to the analog systems. But there was a time where there was a lot of movement trying to figure out, can I trust this thing? Is this digital thing that I'm interacting with the same as this simple off-on that I used before? So how do you help people gain trust in the tools so they can gain all the benefit of having smart infrastructure?
It is difficult for them to learn to trust the newer technologies, but it just takes time. One of the advantages is the visibility with the smarter systems. So if I'm looking at a data center operator and they are normally looking at a screen that shows them a valve is open or closed, but they're having a problem with the space temp or discharge air temperature, they normally only can see a limited view of what's happening if it's open or closed, but they don't know if they have flow rate in that valve. They don't know what the temperature is in that valve. So when we start looking at smarter components, that they have integrated flow meters and BTU meters and other types of inputs coming in, that they can see, oh, my valve is open, but I'm showing zero flow through it. So I know I have a problem somewhere else. It helps them get to that resolution sooner, and that's where we see that they start trusting because they have so much more information at their disposal. I had an interesting case with a data center that was in Taiwan, and they called us and said, we need help with this, and we're losing our space temperature and these certain intervals. We don't know what's going on. So we're able to look at the trends. It happened to be a valve with integrated flow meters. And so we watched when the valve went 100% open, did we have flow or not? We weren't having flow. So they were able to go diagnose in the rest of the system that they had something else closing off, that it gets them to where they need to go sooner. And that's how they learn to trust the smarter systems.
It's so sad experience. One of the other things that I've personally noticed, are we allowed to call people 35 years old and younger young? I'm going to call them young people for the sake of this description. Forever in our industry, for whatever reason, the people that made up the industry were old guys like me. And so to have a woman with your experience is uncommon. We have a number of women in our firm and leadership, but it's uncommon across the board. It needs to be changed, but it was uncommon. And now we have so many people coming into our industry, thank goodness, that are either ex-military, where they have a really rigorous process of learning to trust systems and to integrate new things and to remove things that didn't work. They've got a really rigorous process in learning how to communicate. They have a pretty rigorous process in integrating people that don't look or sound or, different genders and different ethnicities. I mean, to come around a common purpose and a common mission. And so they're because we are an SOP, MOP, EOP driven, a list kind of driven industry, we attract and try to woo veterans into our thing. And so they bring this spirit of innovation with them. Seems ironical, but they do. And then we're attracting so many people that are not traditional guys like me into it because they're looking for a way to feed their family and whatever. It's such a great business to be in, connected to digital infrastructure somehow. And so I feel like at least in part, pressing on other parts of our industry where the norms need to be upset, they bring this sort of, with respect, but this attitude of, well, why don't we do it that way? Or what can we try? Or how does it work? Or there's not enough of us, so we need these tools to come alongside to supplement us. Forever we were so worried that they would replace people. I don't think we need to worry about them replacing people. We need them to augment, whether it's in security or in operational infrastructure that we're talking about today. That's at least in part. And then, of course, the Peter Grosses of the world making fun of us from the stage, as he does on occasion. But in all seriousness, it's this combination of things saying, look, just because we did it that way always doesn't necessarily, it may still be the right way or the right way for now, but we should lean into this smart tech, not at the risk of introducing more opportunities for failure or more opportunities for error. That's not what we mean. But we do mean the ability, presuming they're resilient and have gone through rigorous testing, the ability to help us be much better at what we do.
Absolutely. I think that's a perfect term for it, for augmenting, that we're making these systems where we have that ability to adapt and to augment. I have yet to find anyone who says, I have more than enough skilled labor. So bringing that into the space as well to say we can use some of these smarter devices to help us in our operations today and moving forward, because we just don't have the skilled labor workforce that anyone needs.
Yeah, I haven't heard anybody say that either. So as you guys sit back, how do you interact? I'm curious, at Belimo, how do you find people to engage with, to introduce either new ideas or to listen and learn about what the marketplace is looking for? And let me just give you, just by way of explanation, what I mean. At my organization, because we work with so many large IT firms, some of the largest buyers on earth, we have an opportunity to sit and listen regularly to the problems they're trying to solve, either that they've solved for themselves within their own infrastructure that they've deployed, because many of them own and operate their own infrastructure in addition to using a partner like us. But we get to hear the problems today, whether it's a supply chain or operational or resilience, whatever it might be, and the problems that they imagine 2 years, 3 years, 5 years from now. I'm going to have to deliver an environment that looks like this. Everything from receiving something into the environment, operating it, removing it from the environment without introducing risk that they can't tolerate, has to operate efficiently. That's that agility thing we talked about before. I've got to be able to receive or remove something without putting myself or my customer at risk. So as you look at the designs of today and the designs of tomorrow, how do you guys learn?
So we take a couple of different approaches. The first is proactive. Our traditional approach, we work with consulting engineers, we work with other data center owners, operators, contractors working in this space. We also are heavily involved with Open Compute Project, ASHRAE TC 9.9, the organizations that are talking about that. The other way is we've had many people find us, people that we didn't traditionally work with. Belimo ended up in data centers, I would say almost by mistake. We never focused on any specific vertical market, but we're known for our quality, being a Swiss company. And so we had some pretty big GPU manufacturers and owners find us and say, this is our current challenge. This is what we want to do. We're seeing these devices and we want to improve them and make them better. And so came to us with a specific set of parameters of how they were wanting to scale in the future. And we were able to work with them. And it was nice when you talk about being able to handle the risk that between their test labs and our test labs, being able to play really in a lab environment and figure out how to make them work before they went with full scale deployments.
So I've got to know, and I apologize for not prepping you with this question, although I haven't prepped you with hardly any of these. What's a nice person like you doing in this? Like, what attracted you to being part of an industry like this? And the reason why I ask, I'll just date myself. 25 years ago, 30 years ago, even when I was first going into IT, a lot of the people around me were like, what are you going to do? You're going to fix printer queues or whatever. And if I didn't even really know what a data center was 30 years ago. I don't know if they were well defined, but certainly it is uncommon to have non-traditional engineering men come into our industry. So mechanical engineers, electrical engineers, et cetera, they're just pursuing critical infrastructure. My head of pre-dev, Lainey, is at Georgia Tech, mechanical engineer, young woman. She knew somebody in construction business. She's crushing it. She's been with us for, I think, 12 years now. But again, not a traditional path into our industry. How did you end up working with valves and actuators in the critical infrastructure world, if you don't mind me asking?
Not at all. I ended up in data centers by mistake too. So my degree is in mechanical engineering, and right out of college, I worked for a design build mechanical contractor building entire systems. The first data center I saw was a Chevron data center that ran an oil field. And so that was my first data center almost 20 years ago. Now, after that, I went to work for a controls company. They happened to be a Belimo distributor. So I got even smaller in the systems and then came to Belimo 10 years ago. So went from the full mechanical systems to just controls to just valves and actuators. But it's been very helpful to me to know the entire systems and the path. I ended up in data centers by mistake because about 5 years ago, a friend of mine who worked for a controls contractor went to work for one of the hyperscalers, and they were having some challenges with some of their damper actuators. And she called me and asked for help. And that's how I ended up in data centers, even though I'd worked in some here and there, but very small scale. That's how I started, and haven't looked back since. I love it. The way we keep working on trying to improve and make things more efficient, to make them more scalable, to make them more reliable. It's just fun. It's constantly changing. So that's how I ended up here. And yeah, I love data centers now.
It's almost one of those things where 5 years ago, people would say, what do you do? And you kind of look to the left and you look to the right and say, I love data centers. Like you just, and now it's like, I don't care who knows. I love data centers. I don't know. That's what nerds like us tell ourselves to, celebrate that. Have you, I'm sure, and if you've got something you could share, that's fine. But have you had a problem show up yet that you just sat back and said, you want to do what? Either made you laugh or was a surprise or just, incredible in its scope. You're like, there's not possible. Only to realize not only is it possible, it's probable. Have you had any of those show up yet?
Yes, definitely. And so some of them on the airflow side of just the speed at which they want to do some things, that it's getting into some very I'm going to say uncharted territories for
Hmm.
sure. And
Hmm.
then even on the liquid side, some of the things that they're wanting to do and testing out. Um, Even things with some of the desiccants that I haven't seen anything come to fruition, but people coming to us when they're talking about what media they want to use in the valve body. Like, you're going to do what now? And we'll see. I mean, I don't know. Maybe in 10 years that will become our norm, because even the things we're talking about today, 10 years ago, we probably weren't giving them real credence. So,
Right.
yeah, it'll be interesting to see what they do. The other thing that always makes me kind of tilt my head is all of these companies that have ESG goals and have grand ideas about how they're going to change the way that, or rather change the end result that they're getting, but still the inputs are relatively the same. That it
Right.
makes me tilt my head and say, why are we doing things the same way when we can talk about some new ways of doing things, or newer ways of doing things that get you better results?
See, you're getting a little too personal here because this is NFL weekend. I was sitting there. My wife came in, my wife of 37 years, my beautiful bride, Rita, and without saying much, just kind of raised her eyebrow at me. It's like, I know what that means. I'm like, what? Weren't you just talking about eating healthy and you're going to, or she didn't say you're eating healthy. Were you just talking about working out and you're going to, this is your target? Every year I go through this, my target weight or whatever. Yes. Pretty sure Mr. Dorito is not going to help you there. If same input in, it's going to be the same input out. So I got to download that new dating app and see if I can find someone to put up with me because I can't tolerate her obnoxiousness. Actually, I better not say that very loud. She's half Japanese and half Irish, and I'm terrified of her. So I better clean it up. I just think that here's a thing that is really curious to me. I would love your reaction to it. For the longest time, as I listened to people bringing back design ideas to our organization, we would ask this question, or we'd have a philosophy of how do we remove complexity from the equation? It's easier to operate, it's easier to install, it's easier to change, it's less expensive. All of these. There's a long list on why less complex is better if all things else are equal. When we talk about dealing with much higher density, the way that we're approaching it primarily today is in the same footprint. So I've got to get hotter environments under control in the same amount of square feet, for example. And the way that we're proposing doing that primarily is liquid cooling, some form of liquid to cool it. But that to me implies cost, complexity. Am I thinking of it right? Or is it that the benefit of in that same, for example, we talked about these racks before that were 10 kilowatt racks, so warm but not hot. In the future rack, maybe that's a 70 kilowatt rack or even hotter in the same amount of space. So I don't require any more dirt. And yes, I require the introduction of some way to mitigate the heat, to reject or remove the heat. And so there is some additional complexity, but the benefit outweighs it. How That's a question that we ask regularly, that I ask regularly. Are we introducing a level of complexity that is counter to, and that brings with it its own set of challenges, that is just something we're just going to have to work through? I'm not sure exactly how to phrase that question, but it feels like as we look to solve these density challenges that are in front of us because of the workloads that are in front of us, that we're introducing a level of complexity that we've been trying to avoid for a long time, or at least work design out. Do you guys have that same challenge that you're trying to work through? How do we solve the problem without being more complex? Or is it just not a problem that you've had to face?
It is something that we faced, and what I struggle with in my mind is how you define complex.
Mm,
Because if I talk to, as you put it, someone who's been in the industry for 35 years,
mm,
they're going to probably look at something that is a more advanced component of like a smart valve and say
mm,
that's a more complex product.
mm,
I look at it as being less complex because you don't have a separate valve and balancing valve and all these other components that are separated out. That when it comes to complexity, I look at a smart component as being less complex, where you might have a different viewpoint of that. So
mm.
that's where we struggle of defining that complexity. We're making what are more advanced products, and not just Belimo. A lot of different valve
Sure.
manufacturers are, but making more advanced products that could be seen as complex, but I look at them as being more simple.
Sure. It's having this conversation with somebody, they sort of challenged me a little bit. And they said, well, look, you're going to hop in a car without airbags, or better
Mhm.
yet, you're going to let your new driver, your son or your daughter, without any airbags or any of the quote unquote complex safety systems in that vehicle, or are you going to put them in your 1985 Chevy Chevette that I drove from Atlanta to California and mostly back before it blew up in Tucumcari, New Mexico? Which is it that overall, even if in some ways it appears to have some more complexity, what are you measuring? Are you measuring safety? Are you measuring efficiency? You're measuring cost? You're measuring service? And sometimes I think some of us have this winsome idea of once upon a time I could pop the hood on my truck or my car and I could just go up to the auto store and get my stuff to
Mhm.
replace it. As opposed to in this example, a system that's got all of these components that's very
Mhm.
difficult for me to work on. And I'm not saying that's the same case in the data center space, but for sure, as we're dealing with much higher workloads at
Mhm.
much larger scale, it feels like we have to introduce a level of complexity that for the longest time we're trying to push against. But to your point, I don't know how we do it. It would be ridiculously hard, if not impossible, if we didn't have an intelligence interwoven into the systems. It just wouldn't
Mhm.
be. It just wouldn't be doable.
Absolutely. And that's if we go back to what we were talking about with distributed control systems and whether it integrates into machine learning or artificial intelligence, that from my view, it makes it less complex because everything's there. You're bringing that information together. It's making smart decisions. It's requiring less interaction by people. There's a lot more visibility to data. So even as they're starting to go into it, there's a lot less unknown variables, if you will, than there was in our previous types of designs. So there is that component to it of a lot more smarts
Hmm.
outside of the components that I'm talking about. Overall, we're looking at smarter CDUs, we're looking at smarter chillers, we're looking at smarter even dry coolers, what they can do when they start bringing all of these different components together, and all are becoming smarter than they used to be. We can achieve a lot more with those smart components,
Yeah.
especially as they communicate with each other.
Well, I look forward to the day where these things are, you walk in and it's basically Jarvis. You're talking to Jarvis and they're just, they're having this conversation. We've talked about a lot today. Before I let you go, two quick things. One, what haven't we talked about that we should have? And two, where do you think if today the standard rack density is 10 kW? I ask everybody this. There are some pretty wild guesses. But if a regular data center rack today is somewhere between 8 and 10 kW, let's just assume that's the number. Where do you think we're going to be in a deployment that's being engineered today and deployed in 2025? The IT stack, the whatever. What do you think a standard rack would look like? Is it going to be a little bit more than 10 kW, a lot more? What do you think would be the target number for us to that we'll see?
My guess is 70 kW.
70 kW?
That's And I know that you're saying average, but the more and more I talk to people, I'm amazed at what they're talking. So if you're saying average, I'm saying 70 kW.
70 kW in a couple years. It would be, I would love to be able to buy a rack with the infrastructure that had the ability to start at 10 or 12 and get to 70 within its operational parameters. Kind of like we were talking about that car before that could run at 1 or 2 cylinders and, ramp up to 8 or 10 or whatever at maximum efficiency. Yeah, that would be really cool to see. I haven't seen it yet, but that would be really cool to see. It'd be wonderful for our business. That's for sure. 70 kW. All right. Well, that's a bold statement, Mellissa. I love it. I love it. What haven't we talked about that we should have? We've touched on a lot today.
I think we've covered pretty much all of it. I guess my one ask just from the industry is to be open to doing it differently than we've always done it, because what we're facing ahead is different than what we faced as far as the trajectory of heat loads.
Yeah, my CEO always says, different context, but same idea. We can't solve anything we don't talk about or we won't talk about. And whether it's energy sources, it's talent pools, it's data center design. Like, I want no sacred cows. Let's bring it up on stage. Let's have an honest and transparent conversation. And we may find, well, there's a reason why we don't do something differently than that. Or we may find that the resources or the people or the infrastructure or whatever it is just won't support it, and we need to adjust. I think that's a great idea to be. Imagine that a nice mechanical engineer telling us we need to be open-minded to new things. I dig it. The world's changing. 70 kW. Love it. Thanks for coming on today, Mellissa. I really appreciate it.
Thank you for having me.
My great pleasure. And hey, look, if you enjoyed that conversation, like. And if you loved it, subscribe. We'll see you next time, everybody. Have a good one.